Hi guys, welcome back to the channel and this is Web3 Boy once again. And today we are going to be talking about the fallback problem of OpenZeppelin's Ethernaut and let's just begin this challenge. And first things first, we will be going to review the code first. And I have this app, a very beautiful app that I got to know from one of the YouTubers, and it is very good to keep your notes. So I recommend you all, if you're going to continue your journey on blockchain auditing, just download this app, and it is very beautiful app just to keep your notes very organized, right? So the name of the app is Joplin. You can just go and download it, right? See, I have just made a folder of Ethernaut challenges, and the first challenge is Ethernaut, hello Ethernaut, and the second challenge is fallback, right? I have a complete walkthrough how I will be going to be completing the challenge, and let's just begin the challenge, right? So the first thing is a general review of the code. I'll be doing the general review of the code, and the second thing is I'll tell you about whatever fallback and receive function is that has been used in this particular challenge. And the third thing is I'll tell you guys like how to send a transaction either using web3.js or using a console, right? So let's just go to the Ethernaut challenge, and let's just review the code first. And before doing anything else, I would recommend you to get a new instance. And when you'll get a new instance, I have already told you that it will route you, it will give you a copy contract, like a copied contract of the original contract, and then you'll get the copied contract, and you'll have an instance of it, and you'll have to complete the challenge, and you'll have to submit it to the main contract, right? So one more thing, last in my last video, MetaMask was not popping up, and I was doing everything, but then later on I realized that MetaMask was not working very well, right? So it was not showing, but now it is showing because I had some recording issues, but then it is resolved now. So I'll just confirm it, and you guys will get a new uh, instance of the main contract, right? So let's just do a general review of the code. I'll just open this, and let me just select pencil. Okay. Okay. So here it is. This one is, I think the pencil is not selected. Let me just select it once again for you guys, and then okay. Okay. So here it is. Let me just zoom it for you guys so that you guys can see it. Mm, Let me just, I'll increase it for you guys, otherwise it will not be visible for you guys, right? So I'll just this is the pencil. Okay. So here is the code. So first thing is this one, SPDX license identifier, and I missed it. So this is the license, right? Every time you have to every time you write a code in the Solidity, you have to put in the license. So I'll not be doing it from, I'm just telling it you guys, I'm just telling it once. I'll not be doing it in the next video, right? So this is Pragma Solidity 0.8.0, and when you write the code, you have to specify the version of the Solidity you guys are going to write your code in, right? So for this particular code, they have given 0.8.0, and the special thing to note here is this cat sign, right? So this particular thing tells you that whatever you guys are going to, I mean, this particular thing tells you that if you're writing a code, and if you have been you have written a code, so if you say that this Solidity version must be greater than 0.8.0, That means any solidity compiler above 0.8.0 will compile it, but not below that, right? So this is absolutely, not recommended. If you are doing it for the testing purpose, it is recommended. But when you are deploying it on the mainnet, it should you should freeze your contract, right? It should not, there should not be any caret sign, right? And then second is, let's start the contract. This is our contract. Contract is fallback. The name of the contract is fallback, and then we have a mapping, and this mapping is from addresses to uint, and the visibility is public, and the name of the mapping is contributions, right? So whatever contributions you guys, anybody who is making the contribution from some address with some value is going to be mapped in the contributions mapping, right? And then we have an owner, and owner has an address type. And then let's move on to the next constructor. So we have this constructor, and I've already told you guys that constructor is a special function, and it only runs once in a program, right? So the constructor says that owner is owner is equal to message.center. Why isn't it? So owner is equal to message.sender, right? So whosoever is deploying the contract must be the owner of the contract, right? In this case, in this particular case, Ethernaut is the owner of the contract, right? And this is the contributions, this is the mapping of the contributions, and this particular code base says that whosoever is deploying the contract must send is giving the contributions of 1 ether multiplied by 1000 ethers, right? And let's just move on to the next line. Here only owner, okay. So we'll just be doing this, and I'll be just removing everything here. Okay, so we have what is next? We have a modifier, right? We have this modifier, and what modifier is, it's like you are telling your contract to, let's say you have a modifier with some particular name, and if that particular name is added before after any of the functions, then that function has that capability to call that modifier, and whatever is written inside that modifier will be executed, right? So let's just get into it, and I'll tell you what it is. So modifiers, the name of the modifier is only owner, and it says require message.sender is equal to owner, right? And if it is not true, it will return caller is not the owner, right? So what do you mean by this? So if you the name of the modifier is only owner, and it says message.sender must be equal to owner, that means whoever is sending this deploying this contract is the owner of the contract, right? And caller is not the owner. If the owner of the contract is not calling this, is not calling that function, then it will return caller is not the owner, right? And one more thing about a modifier is that, let's say this is special, this particular code base is written here, and after executing this particular thing, right, then it will move on to the later part of the code, right? This particular underscore is the later part of the code, right? So for giving you an example of how a modifier is used, here in the function withdraw, it has the modifier only owner, right? So whatever is written, withdraw must be called by this particular modifier, and whatever is written inside this code, this code will be executed only after this particular requirement is met in the modifier. If it is not met, the code that is calling the modifier will not be executed, right? So in this case, function withdraw has only owner modifier, and if that particular condition where it says message.sender must be equal to owner is met, then this code base will be executed, right? So again, coming back to the code, this is completed, and then this is the contribute function. The contribute function basically is a payable function, and it says message.value must be less than this particular ether amount, and also it maps to the contribution. Whoever sends to this particular whoever sends ether using this contribute function, and whatever the value he is sending will be mapped to these contributions. And again, it is saying that if contributions of message.sender, if the contribution of whoever is calling this particular function contribute is greater than contribution of the owner is equal to message.sender, right? It says, if you're contributing and if you're contributing more than the owner, but in our constructor function, it says owner has sent 1000 ether, right? So you cannot send 1000 ether, and just because it says you have to send a require message dot value must be less than is equal to 0.001 ether. So you will be sending less than 0.001 ether, and that cannot be greater than this particular amount of the ether. So you can never be an owner by calling the contribute function, right? So you cannot send more than this much ether, and it says if your contribution is more than the owner's contribution, then you are the owner, but you are not the owner just because you are sending less than 0.001 ether, right? So this is the contribute function. This is get contribution. You can call the contribute get contribution function. You can call this function contribution function. No, sorry. It will just return the contributions of message.sender, right? Whoever is sending the ether to the contract, you can just call that particular mapping with the index number, and it will return you the value, right? And then you have this withdraw function. I have already discussed about it, which has this only owner function and only owner modifier, and this will execute accordingly. And then last but not the least, we have this receive function, right? So I'll discuss about it in detail, but let's just go back to our Joplin, and okay, we have discussed the general review of the code. General review of the code has been done. Now let's move on to the next part. So the next part is what is receive and fallback function, right? So I'll just go back to this. Just let me just zoom it out for you. It's too much. Okay, so here it is. What is fallback function? I have made this small. I've taken it out from internet, obviously, but there is this link, and I'll just when I'll just open this particular link, it'll take me to this solidity documentation, solidity documentation. So let me just tell you what, in a layman's language, let me just tell you what a receive and a fallback function is, right? So let's say you have a contract and you want to send some particular Ethereum amount in that particular contract, right? But that contract does not have any special function to receive the ether, right? So if you do not have any special function to receive the ether, there is a special function, that is a receive function, that will receive the ether, right? Whatever is written inside the receive function, it will receive it. It will do that, right? So basically, if a contract does not have anything, if the contract does not have any special function to receive the ether, it will automatically execute the receive function, right? But receive function only receives the ether, and the fallback function receives the ether along with some call data, right? So this is it, guys. and you can just go back to this particular page. I'll link it in the video, and then you guys can read about it a little bit more. And so this is the diagram. Let me just discuss it. So let's say this particular diagram says which function is called fallback or receive, right? So let's say if you do not if you send some ether to the contract within the contract, and let's say if the contract does not have any special function um, with with that receives the ether. So the contract will first check for, let me just open this. Okay, so the contract, when you are sending the ether, right? Color is too messy, I'll just change the color. I know. Okay, so when you send the ether, the message dot data is empty, right? If you're not sending any data to the contract along with the ether, it will check. I mean, it will check if the message dot data is present or not. I mean, if you are sending some data to the contract along with the ether or not. So if you are just sending the money, I mean, if you're just sending the ether in the contract, it will go to the receive function, right? And if you are if you are sending data, I mean, if you're just sending the data, message dot data is empty. If it is not empty, it will go to the fallback function, right? But if it is empty, so it will go to the receive function. But if there is no receive function, it will go to the fallback again, right? So this is it, guys, and you can just read more about it in this particular link. And let's just go to the next part. What is the next part? How to send a transaction to a contract, right? So sending a transaction to a contract, I'll just come back later. I'll come back on it, but let me just go back to our console and check how, like, let's just see what what this challenge is trying to say, like what this particular contract is making us do. So let's just zoom it out, zoom it in. Okay, here it is, right? So this is saying that okay, so this is saying, look carefully at the contract code below. You will beat this level if you claim the ownership of the contract, right? You'll have to claim the ownership of the contract and you reduce its balance to 0, right? And it says things that might help. How to send ether when interacting with ABI, how to send ether outside of the ABI, converting to and from way ether units, and fallback methods. So fallback methods we have discussed already. We have already got a new instance. Let's just check name await contract. Let's just see the contract address. So here it is. This is the contract address, right? And after contract address, what we'll do is I'll just show you how many addresses we have. Await contract dot owner, right? We'll see the owner's address, okay, and then we'll see the player's address, right? Await player, right? So we have this address is us. This is our MetaMask address. You can cross check it. You can go to the MetaMask and then confirm it. We have this 0x7fd and we have 0x7fd, right? This is our address. This is the owner of the contract's address. That is the instance address, I guess. And this is Ethernot's address, right? Okay. So what it is saying is you have to send ether to the contract. So let me just one more thing is the receive function will only trigger when when it says require message dot value must be greater than 0. I mean, you have to send more than 0 Wei. Wei is the smallest unit of the ether, and you have to send at least one Wei, right? So I'll send one Wei, and contribution of message.sender must be greater than 0. I mean, whosoever is sending some ether to the contract must have contributed before, then only receive function will trigger, right? So first what I'll do is I'll contribute to the contract, and then I will my address will be mapped to a certain value in the contract, so I have already contributed. So this part is already met in this particular function. Like when in the second part I'll be sending a transaction to the to the contract, so I'll not be sending the transaction using the contribute function, right? So it will trigger the receive function, and when it will trigger the receive function, it will check for contribute whether I have contributed already or not, and if I have already contributed, whether I am contributing more than 0 Wei, and if both of this is true, the owner is equal to message.sender. I mean, we will get the ownership of the contract, right? So first what we'll do is we will do await contract dot, we have contract dot contribute, and then how we will send is we will send a value, and that value must be equal to 1, or let's say 4 I will be, or let's say 3 I will be contributing 3 Wei, right? Okay, so I have not contributed, like I have not called the contribute function. Here it is. Okay, contribute. Okay, now it will trigger my transaction, and MetaMask will pop up, and we'll just confirm the transaction. After confirming the transaction, it will go through, and our contribution to the blockchain will be shown in the mappings, right? So let's just show you await contract dot contributions, right? When I will call this, got 0 and expected 1. Okay, contributions I will say 1. Okay, contributions I'll have to send an address. Oh, I'm sorry, I will just do await dot ABI. I will do the ABI, right? So when I do the ABI, and where's the contribution? Here is the contribution. Let me just check if I can do the get contribution, right? Await contract dot get contribution. Okay, so here it is, and in the get contribution we have like this. When you open this one, and you will open the words, it will show that we have contributed 3 Wei, right? So I have already contributed to the contract. Now is the time to send a transaction without calling any contribute function, right? And when we will do it, we have already contributed, and we will send some Wei to the contract, and a receive function will automatically trigger, because I'll not be sending some Wei to the contract without with calling the contribute function. So a receive function will trigger automatically, right, for receiving the Wei. So I'll do await. One more thing before doing this, I will show you who is the owner of the contract, right? So I will do await contract dot owner, right? When I will do this, so this is the owner of the contract. and obviously this is not us because our address is something different, right? So we are not the owner, right? This is us, and we'll have to take the ownership of the contract. So I will be sending a transaction again. So I will do await contract dot send transaction. And for anyone who does not know how to send a transaction, I will just I'll just link this page sending a transaction to the contract. When you open this particular page, this is Stack Exchange, Ethereum Stack Exchange. You'll open this, and going below you'll see this particular you know you'll see this particular thing, right? So this is how you will be sending it, right? And you can read about it. I'll not be explaining it much here. And basically this is one more web3.js explanation of like how to send a transaction. And this is basically how you send. When you use the web3.js library, you'll be sending a transaction using web3.eth. But we are sending a transaction using the console, right? So we'll not be using web3.eth send transaction, and instead of that we'll be just using this I mean contract dot send transaction. But inside this, how we'll be sending is we'll be just taking this value, key pair, right? This is the key, this is the pair, this is the key, this is the value, this is the key, this is the value, right? So we'll take the key, and key is equal to key is value. So, and how much are we sending? We are sending greater than 0. This must be greater than 0, right? So we'll be sending how much? We'll be sending at least, let's say we'll be sending 1. And after doing this, it will trigger a transaction, and MetaMask will pop up, obviously. So you'll have to confirm it, and let's just confirm it. I have confirmed it, and after this has been confirmed on the blockchain, you can just check on the Sepolia Ether scan, right? So my blockchain transaction has been confirmed. Let's just check who is the owner of the contract now. I hope this is us, and if this is us, then congrats to us. So I'll check this, and voila, we are the contract owner. So here it is, 0x7FD, and we are the owner of the contract. And I'll just make this happy faces again, so that this is very important for me because it makes me feel good. So this is my eyes, this is, I don't know, my nose, this is my pretty smile. Okay guys, so this is it, and we have basically completed the challenge, and we have taken the ownership of the contract. And after completing this, you can just submit the instance to the main contract of Ethernaut, and after doing this, it will say that yes, you have completed the challenge, right? And so I think the video is too long. I don't know if you guys will like it or not, but if you guys liked it, please subscribe to my channel and share it with your friends, so that I'll get the maximum reach. I'll be doing this every day for like this month, and later on I'll be doing a damn vulnerable DeFi also. Okay, so it says looks like you haven't cracked this level yet, so I guess we'll have to extract everything out of the contract also. So I'll be just doing it right now. Okay, so after doing this, I guess I missed this second step that says you reduce its balance to 0. So what we'll have to do is you'll have to just do await contract dot withdraw, right? And when you do this, it will withdraw everything from the contract, right? So I have claimed the ownership of the contract and I'll reduce its balance to zero, right? I'll just confirm it, and ownership has already been claimed, and now the balance of the contract is also zero, and now I'll submit the instance and let's see if it is, if we have completed the challenge or not. I was very happy, but I think I should have waited, but let's see. I hope it does not fail this time. I don't know why it is taking too long. Okay, here it is. Well done, you have completed this level. Okay, so we have completed this level, guys, and this is it. And if you have liked this video, please subscribe to my channel, and I'll be seeing you in the next video and the next challenge of the Ethernaut. And till then, bye bye, see you in the next video.